Hi, everyone, and welcome to my next installment in this algebra and pre-calculus video series. This is a big turning point for us because from this video on, from now on, we're going to be talking about different type of function than we have so far in the previous, I don't know, 20 or 30, however many videos there's been. We've talked about linear functions and quadratic functions and polynomial functions, rational functions, exponential functions, logarithmic functions. And all of those functions have worked pretty much the same way. A function is like an input-output machine, right? You got a function, we'll call it f of x, right? And we take a real number, plug it into the function. So we'll say real number here. Function does something to it and then spits out another real number. Right, so that set of inputs we call the domain, those are the x values, and the set of outputs we call the range, those are the y values. So what we're going to be doing now is we're not just plugging in any real number into our function. Let's cross that out. What we're going to be plugging in is an angle. So an angle goes in and the function spits out a real number. So this video, we're not going to be talking about functions or graphs or domains and ranges or anything like that. If we're eventually going to be talking about functions where you're plugging in angles, your input values are angles, well, we have to talk about angles. All right, so this video is entirely going to be on angles and angle measure. Okay, so before we get into anything, before we even get into anything on the screen right now, all right, there are about, I think at last time I checked, 198 countries in the world. And of those 198 countries, if someone asks, how tall do you think I am? In 195 of them, they're going to tell you some number of centimeters, but not in the US, not in America. In America, we use inches and feet, right? So inches is 1 unit of length, and centimeters is another unit of length, right? Two completely different scales of describing the same thing. Two different scales of saying the same thing. Well, I grew up in America, so if someone asks me how tall I am, I'll say it's about 5'11". Oh, I don't know what that means. How many centimeters tall are you? I have no idea. I don't know. My brain doesn't work in centimeters because I didn't grow up using centimeters. But whether or not you're familiar or comfortable with working in both scales, I'm hoping everyone is at least familiar with the existence of these two different units of measurement. We have the metric system, which most of the world uses because it makes sense. And then we have the other one, the one we use in America, the imperial system or the British system, the one that doesn't make sense. All right. The reason I'm bringing this up now is because there's two different measurement systems that we're going to use for angles. And I'm going to be talking about both of them in this video. Hopefully, at least one of them you have heard of before. Degrees. A right angle is 90 degrees. A full circular rotation is 360 degrees. Okay, so it turns out degrees is not the most convenient scale to work in. So we're going to be describing angles using another measurement scale. And I'll get to that in a little bit. So first off, let's talk about the definition of an angle. What is an angle? Well, an angle is the rotation between two rays. A ray is an infinite line that only goes in one direction, right? A line is infinite in both directions. A ray has a starting point but no ending point. So once you have two rays that have a common starting point, right? We call this the vertex. Call this the vertex. Well, that rotation between the two rays, that's an angle. All right, so if you have two rays starting at the same point, you have an angle. Notice this angle here is labeled with this Greek letter theta. For linear, quadratic, polynomial, rational, exponential, logarithmic functions, our go-to variable was x. We use x for our variable. When we're talking about angles, we're going to be using Greek letters. We're going to be using Greek letters. So here's 4 of them. There's many more. There's a whole alphabet. All right, there's alpha, beta, theta, gamma, many more. You're probably familiar with the Greek letter pi, hopefully. That's another Greek letter. We're not going to use pi for angles because pi has another specific meaning. But we're going to be using Greek letters for angles. And theta, right, get used to it. Get used to theta. Theta is going to work like our x, our most common variable when we're talking about functions and angles. Okay, so we need to be consistent. So everyone has to be doing things the same way. And to do that, we're going to label one side or one of the rays as the initial side. This is the one that doesn't move. Right? The initial side doesn't move. The terminal side, the other ray, that's the one that's rotating. Okay? Think about the hands on a clock. Right? The hands on the clock rotate. After 1 comes 2, after 2 comes 3, after 3 comes 4, then 5, then 6, then 7, then 8, then 9, then 10, then 11, then 12. What number comes after 12? Well, it ain't 13 because there's no 13 on a clock. After 12, you're back to 1. All right, so we're going to be looking at this cyclical or circular number system, right? Our number line is going to look like this. It's no longer a straight line. We're talking about angles. Angles are rotations, right? Okay, so we're going to label our angles with Greek letters, lowercase Greek letters, usually, not always. That's the uppercase beta, but Greek letters. All right, so let's move on. For an angle to be considered in standard position, the initial side or the starting side is going to be at the positive x-axis. So this one doesn't move. This blue one does not move. That's the initial side of the angle, or the initial ray that forms the angle. And then the other one is the one that's rotating, the one that's moving, the terminal side. And also, just to be consistent, so everyone is doing things the same way, positive angles are rotating in the counterclockwise direction. Counterclockwise. Negative angles. So you're basically a positive angle, you go up from the x-axis. Negative angles, you go clockwise, down from the positive x-axis. Negative angles are a clockwise rotation, the same direction as a clock. All right, so this angle here, alpha is positive. Alpha is bigger than 0. It's a rotation in the counterclockwise direction. Over here, theta is a negative angle, less than 0. It's a rotation in the negative direction. And this is important because we all have to do things the same way. So there's some consistency in how we work with angles. So we all are in agreement. We're all in agreement that the initial side is the positive x-axis. And then the rotational side, or the terminal side, depending on if the angle is positive or negative, the terminal side rotates counterclockwise for positive angles, clockwise for negative angles. Okay, so we have to talk about measuring angles using this other measurement system called radians. Radians is an alternative to degrees. Right? Just like you could measure something in inches, and you could also measure it in centimeters. You can measure something in pounds and ounces. You can measure something in grams and kilograms. Right? You could measure an angle in degrees. And you could also measure an angle in what are called radians. It's just another system of measurement. Now, what is a radian? So we have to spend a little bit of time talking about radians. I'm going to operate under the assumption that none of you have heard the word radian before. I'm assuming you have heard degrees, but not radians. I mean, even if you've heard of degrees, maybe you don't know the formal definition of what is a degree. What is the definition of 1 degree? Well, 1 degree is defined as, the definition of a degree is 1/360th of a circular rotation. One 360th of a circular rotation. What's so important about the number 360? I don't know. I don't know. It turns out that mathematically, measuring angles in degrees, like 30 degrees, 40 degrees, 90 degrees, 110 degrees, things like that, it turns out that measuring angles in degrees is not the most convenient system of measurement. Right? Just like metric versus imperial. Right? We know 1 kilometer is equal to 1,000 meters. So if I was to ask you, how many meters are in 3 kilometers? Well, it's 1,000 a piece, right? So that's pretty easy to do. There's 3,000 meters. 1 kilometer is 1,000, so 3 kilometers is 3,000. Well, if you talk about what we do here in America, 1 mile is 5,280 feet. Well, how many feet are in 7 miles? I have no idea. I need a calculator, right? It's not convenient. They're not nice, easy numbers to work with. So the metric system for all types of measurement is more convenient. And it turns out with angles, the radian measure which we're going to start talking about now. Basically, this whole video is about radian measure. Is a much more convenient system of measuring angles. So the radian measure of an angle, in this case, we're calling it angle beta, is the length of the intercepted arc divided by the radius. What in the world does that mean? Well, let's start with something we know. Here's the XY plane. Horizontal axis is the X, vertical axis is the Y. And let's put a circle on the XY plane. So the center of the circle is the origin. We've talked about what it means for an angle to be in standard position. One of the rays is on the positive x-axis. The other ray is somewhere else. And then between the two, the rotational distance between the two is the angle. In this case, we're calling it beta. Well, the length of the intercepted arc. So let me do some highlighting here. The length of the intercepted arc is this portion of the circle that I just highlighted yellow. That is the arc. We call that a piece of a circle. We call it an arc. A piece of a circle. And the radius of a circle is this green line right here, the distance from the center to the circle. Right, that's the center. That's the radius, R. And our notation for the length of the intercepted arc length, we're going to use the letter S. Lowercase s means arc length, the length of a portion of the circle. Now, we've seen this before. I mean, you've definitely seen this before. The length of a circle. We have a word for this. We call it the circumference. The circumference is the length of the entire circle. The circumference is the length of the entire circle. So an arc is part of the circumference. I mean, it could be the whole circumference. If your angle is 360 degrees, or it could be part of the circumference. Okay. So we know, forget about all of this right now. We'll get to that in a moment. The definition, again, I said this already, the definition of 1 degree is 1/360th of a circular rotation. And so basically, if you have a circle and you split that circle up into 360 tiny little slices, 1 degree is the angle that sweeps out one piece, 1/360th of the circle. Okay, so that's a degree. That's the definition of 1 degree. And if you sweep out the entire circle, that's 360 degrees. So now let's define 1 radian. The definition of 1 radian. right? It's just a different unit of measurement, right? If you sort of make connections between this and something you already are familiar with, things might start clicking, right? Pounds and ounces is one unit of weight. Grams and kilograms is another unit of weight. So this is the same thing. Two different units of measurement, Fahrenheit and Celsius, right? 0 degrees Fahrenheit is not the same as 0 degrees Celsius, right? Water freezes at 0 degrees Celsius. If we want these two to be equal, we would need 32 degrees Fahrenheit is equal to, it's the exact same temperature as 0 degrees Celsius. All right, so if a temperature changes or increases by 1 degree Fahrenheit, that is not the same as 1 degree Celsius. All right, same thing is true for degrees and radians. 1 degree and 1 radian are not the same thing. The definition of 1 radian is the angle. Right, this angle right here, I just highlighted in yellow, is the angle that sweeps out a part of the circle. Right, this is the arc, or what I just made red, that is the arc. Whenever that arc is the exact same length as the radius, when those two are equal, the angle is 1 radian. The angle is 1 radian. So let me draw 2 more circles down here. Let me draw 2 more initial sides. And 2 more angles. Let's call this alpha and beta. Well, alpha is smaller. Alpha is smaller than 1 radian. You know, just by the looks of it, it looks like it's more than 1 degree, but it's less than 1 radian. And then beta is larger than 1 radian. Right, so you think about that terminal side is rotating. When the terminal side rotates enough so that the arc is exactly the same as the radius, we call that 1 radian. So 1 full circle in degrees, like first in degrees, a full circle is 360 degrees. But a full circle in radians is somewhere between 6 and 7. I'm just looking at this picture right here, right? If that red, like what I have here in red and yellow, if that's 1 radian, well, to make the whole circle, it looks like it's only a little more than, maybe more than 6, less than 7. Right? But it's a different unit of measurement. The radius doesn't matter, right? So if the radius is bigger, the arc length is bigger. If the radius is smaller, the arc length is smaller. But either way, like the size of the circle doesn't matter. We're talking about the rotation of the terminal side. Okay, so we've talked about the definition of a radian. 1 radian versus 1 degree. One thing that we're definitely going to have to be able to do is convert between radians and degrees, degrees and radians. If I say to you right now, take out a piece of paper and draw an angle of 6 radians, what does that look like? I don't know. If I say draw 30 degrees or 110 degrees, that makes a little bit more sense. So sometimes it's going to be beneficial to convert radian measure into degree measure so it starts making more sort of visual sense. Now, let me ask you another question. How would you do this? How would you take the fraction 3/5 and add 1/10? How would you take 3/5 and add 1/10? Well, we can't. We can't add these two fractions together because they have different denominators. Right? If we're going to add, if we're going to do this, we have to have the same denominator. So what we do is we get a common denominator. What does that mean? To get a common denominator. Well, the first fraction is over 5. The second fraction is over 10. If they were both over 10, then we could add them. All right, so we'll take the first fraction and change that 5 into a 10. The way we do that is we multiply by 2 over 2. And the reason we're allowed to do that is because any number over itself is equal to 1. So we're basically multiplying by 1. So we get 6 over 10 plus 1 over 10, and that is equal to 7 over 10, right? So the way we add fractions is by taking one or both of those fractions and multiplying by 1 in a different form, not the number 1, but in this case, 2 over 2. So we're allowed to multiply anything by 1 without changing the meaning. We've seen this before. So let me ask another question. True or false? 1/2 equals 6. True or false? Well, I think it's pretty obvious. These are two different numbers, so the answer is false. They are not equal. 1/2 and 6 are two different numbers, but if I start giving meaning to these numbers, 6 eggs, 6 eggs, are they equal? Like what I just wrote in red. Now, are they equal? Well, yes, they are equal because they mean the same thing. Different numbers, but same meaning. Same meaning. Okay, one more piece of the puzzle, and then we can move forward. What is the circumference of a circle? Now, you may remember this, or you may have to look it up, but the formula for the circumference of a circle is 2 times pi times r. 2 times pi times the radius. That is the formula for the circumference or the distance around a circle, the length of a circle. Right, so that's equation number 1. Then we've got the arc length. Arc length is equal to r times theta. All right, now think about this. What angle gives you a full circle? One full circular rotation. Well, that's 360 degrees. So when the angle is equal to 360, you get a full circle. That means you get the circumference. Then the arc length is equal to the circumference. S equals C. So r times theta is equal to 2 times pi times r. Now this is an equation. We have an r on both sides. So if we divide both sides by r, we get theta is equal to 2 pi. When you are talking about one full circle, one full circular rotation, your angle is 360 degrees or 2 pi radians. 360 degrees or 2 pi radians. So that is it. Like that is our connection right here. This is super important, right? That is our connection between degrees and radians. 360 degrees is equal to 2 pi radians. That is our conversion between the two. One full circle is 360 degrees. One full circle is 2 pi radians. So 2 pi is not exactly, but it's about 6.28. So one full circle is bigger than 6, less than 7, somewhere between 6 and 7 radians. Now, it's usually not given this way. Usually not given this way because 360 is divisible by 2. So if we divide both sides of this equation by 2, we get 1 pi radian, half a circle, is equal to 180 degrees, half a circle. Right? This is one of the most important things that we're covering in this video. 360 degrees as an angle is the same as 2 pi radians an angle. Or we could say half. Let me just write this in here. Pi radians is a half circle. A half of a circular rotation. 180 degrees is a half of a circle. Half of a circular rotation. So in the same way, 1/2 dozen eggs is the same as 6 eggs. These two guys are equal. Pi radians and 180 degrees. So this fraction right here is equal to 1 because the top and the bottom mean the same thing. Pi radians is a half circle. 180 degrees is a half circle. Top and bottom are the same half circles. So when the top of the fraction, the bottom of the fraction are the same, this is just like 2 over 2 is equal to 1. Top and bottom are the same, fractions equal to 1. Doesn't matter if the radians are on top or the bottom. They're equal to 1. These two fractions are equal to 1. So we're going to use these. We're going to use these two red boxes right here. This one and this one to convert between radians and degrees. Okay, we're going to do some problems. We're definitely going to get to some problems, but this is a sort of a new topic. So there's a little bit of foundational discussion that has to happen first. So let's take that last slide. Let me rewrite what we had on the previous slide. Pi radians over 180 degrees is equal to 1. And 180 degrees over pi radians is equal to 1. You are allowed to multiply any number by 1 without changing the number, right? Any number times 1 is equal to itself. Any number times 1 is equal to itself. So 55 degrees times 1 is equal to itself. 55 degrees. It doesn't change the meaning of the angle. Okay, but that's not what we want to do here. What we want to do is convert the following angles in degrees to radians. Right? So we want to go degrees to radians. So in essence, what we are going to do is take 55 degrees and multiply it by 1 to turn it into radians. 55 degrees times 1. But we're not going to use the number 1. We're going to use something that's equal to 1. These guys over here. Okay, so which one do we use? The top one or the bottom one? The pi over 180 or the 180 over pi? It depends on what you want to get rid of. Now, we're going to take 55 and multiply it by one of those. Those are fractions. All right, so let's start off by turning the 55 degrees into a fraction. That's 55 degrees over 1. If we want to eliminate degrees and change it to radians, we want degrees on the bottom. Because units cancel just like numbers. If you have a 2 on top and the 2 on the bottom, they cancel. If you have a 5 on top, a 5 on the bottom, they cancel. If you have degrees on top and degrees on the bottom, they cancel. Units cancel just like numbers. And so degrees on top, degrees on bottom, they cancel. So if we multiply top times top, bottom times bottom, 1 times 180. We get 55 pi over 180 radians. Now we definitely want to reduce this. We want to always simplify our answer. So let's see, 55 is 5 times 11. So we got 55 pi is 5 times 11 times pi. And 180 is also 5 times something. I think it's 5 times 36. So those fives cancel. And we get 11 pi over 36 radians. And so 55 degrees means the same as 11 pi over 36 radians. Those two are equal. So we can do the same thing with 210. 210 degrees over 1 multiply by pi radians over 180 degrees. So we get 210 pi on top, 1 times 180 on the bottom, degrees on top, degrees on bottom, cancel. So the units left are radians. Two ten is 7 times 30. 180 is 6 times 30. So this reduces to 7 pi over 6 radians. Again, 210 degrees, 7 pi over 6 radians. So in this problem, we went from degrees. We start with degrees, change it to radians. We could go in the other direction. Start with radians, change it to degrees. So again, just like I had on the last slide. (180 degrees over pi radians is equal to 1. Or pi radians over 180 degrees is equal to 1. Right? This is nothing new. This stuff you've seen before. You know 12 inches is the same as 1 foot. 12 inches is 1 foot. So the fraction 12 inches over 1 foot is equal to 1 because the top and the bottom mean the same thing. The difference here versus the last problem is we're going to use this one. Instead of pi over 180, we're going to use 180 over pi. Whatever unit you want to eliminate goes on the bottom. Right? Whatever unit you want to eliminate goes on the bottom. So we have 5 pi over 3 radians. So we're going to multiply radians on the bottom. The radians cancel radians. And actually pi cancels pi. We have a pi on top, pi on the bottom. So we get 5 times 180 degrees over 3. 5 times 180 is 900. And 900 over 3 is 300. So 5 pi over 3 radians is the same as 300 degrees. A little bit less than one circle. A full circular rotation is 360. This is 300. So a little bit less than one full circle. So we could do the same thing with, oh, meant to do a pin. 7 pi over 4 radians. Multiply that by 180 degrees over pi radians. So pi radians on top, pi radians on the bottom, cancel. We get 7 times 180 degrees, all divided by 4. And we could simplify this. 7 times 180 is going to be 1,200 and something, 260. And when we divide by 4, we get 315 degrees. Seven pi over 4 radians is equal to 315 degrees. Okay, so converting back and forth, converting from radians to degrees, degrees to radians, you're using these conversion factors. These two guys right here. Okay. Let's do the same thing, but instead of getting an exact answer, let's use a decimal approximation. So convert the following angles in degrees to radians. It's the same conversion, 180 degrees and pi radians mean the same thing. So when we take, let's say, for example, 165 degrees, we're going to multiply it by one of those fractions. So let's turn this into a fraction over 1. We want to get rid of degrees, so we'll do degrees on the bottom, which means pi radians go on top. Degrees on top, degrees on the bottom cancel, so you're left with radians. So we have 165 pi on top divided by 180. 165 pi divided by 180 radians. This is the exact answer. This is the exact answer, but we're not looking for an exact answer. We're looking for a decimal. Round your answer to 2 decimal places. What is 165 times pi divided by 180? I don't know. This is what calculators are for. So 165 times pi. So pi is second caret. There's pi. Don't use the number 3.14. 3.14 is not pi. 3.14 is close to pi. It's almost pi, but it's not exactly. So use the pi key on the calculator. 165 times pi divided by 180. And there's our decimal approximation. I don't know. If we round it to, let's say, oh no, we're rounding to 2 decimal places. 2.879. So that would be, if we round it, 2.88 radians. .88 radians. The same thing with negative 104 degrees. We want to convert that to radians. We'll put degrees on the bottom, radians on the top. Degrees, cancel degrees. And so we have negative 104 pi divided by 180. Again, this is the job for the calculator. Negative 104 times pi divide by 180. So rounded to 2 decimal places, it looks like negative 1.82. Negative 1.82. I shouldn't be using an equal sign. I should be using a approximately equal sign. Because when we calculate this, it's not negative 1.82, it's negative 1.815142422 dot dot dot. And so if we're rounding, we're slightly changing the number. So it's approximately equal to negative 1.82. Negative 1.82 what? Well, radians. We're converting to radians. Okay, looking good, looking good. So number 1 and 2, radian to degrees to radians. Exact answers. Numbers 3 and 4, same thing, but decimals, decimal approximation. So if we start with 10 radians, and we want to change this to degrees, we put radians on the bottom. So 180 degrees go on top. Top times top, bottom times bottom. We get 1,800 degrees divided by pi. Radians on top, radians on bottom, they cancel. We're left with degrees. Degrees. So what is 1,800 divided by pi? Again, I have no idea. 1,800 divide by pi. So it's about 572.96 degrees. It's about 572.96 degrees. All right, next one. The same thing. We have an angle that's given in radians. Theta equals pi over 53 radians. Convert that to degrees. So we'll take pi over 53 radians, multiply by 1. So multiply by 180 degrees over pi radians. So radians cancels radians. Pi cancels pi. And we're left with 180 degrees over 53. So again, it's a job for the calculator. 180 divide by 53. Rounded to 2 decimal places. 3.396. So it looks like about 3.40. 3.40. Right, this is degrees. Okay, got a couple more to do. So I want to cover all of our bases, right? So draw an angle in standard position and state the quadrant. State the quadrant. So this would be quadrant 1, quadrant 2, quadrant 3, and quadrant 4. 1, 2, 3, 4. So let's think this one through without converting to degrees, right? Without changing the pi over 3 radians to degrees. Now, before we do anything else, just look at this. You see pi, or you see theta equals pi over 3. Well, pi over 3 what? What's the units? So what we're going to do is just sort of use a little bit of shorthand notation. If we're talking about degrees, so for degrees, we need the degree symbol. That means 4 degrees. So like theta equals 4 degrees. But if you see theta equals 4 with no degree symbol, we're not going to write the word radians every time. Right? It's too much. It's too much. So it's just like a square root, right? You know there's a 2 right here. We just don't write the 2. Just shorthand notation. So if you see theta equals 4 with this little circle up here, that's 4 degrees. If you see theta equals 4 with no degree symbol, That's going to be radians. Right? So you see here, theta equals pi over 3. We know it's radians. We know it's radians because there's no degree symbol. Okay, so let's think this one through. We know this, 1/2 of a circle is an angle of pi, right? A full circle is 2 pi. A half circle is pi. Right? It's very important. So we don't have pi, we have pi over 3. So if you take a half circle and you slice it up into 3 equal pieces, right? If you slice it up into 3 equal pieces, well, if the entire half circle is pi, well then this angle right here is pi over 3. This angle right here is pi over 3, and this angle right here is pi over 3. Right? A third of a semicircle is pi over 3. So drawing that in standard position, we're going to use the green one. We're going to use the green one. Initial side at the x-axis. So that angle of pi over 3 is going to put us in quadrant 1. The second one, theta equals -3 pi over 4. Well, negative pi looks like this. Pi is a half circle. So negative pi is a half circle in the negative direction. Right? So that's negative pi. But here we're dividing by 4, right? So if you take that negative pi and divide it up 4 ways, this would be -1 pi over 4. This would be -2 pi over 4. And this would be -3 pi over 4. So the angle in standard position would be this one right here. This would be -4 pi over 4, which is negative pi. All right, so going in the negative direction, -1 over 4, -2 over 4, -3 over 4, -4 over 4. So we want -3 over 4. So there's the angle. And that puts us down here in quadrant 3. So a positive angle and negative angle are going to put you in different places on the circle. So let's do another one of these problems, but instead of radians, let's use degrees. And in this case, I have the same angle. One positive, one negative. So when we're talking about degrees, 180 degrees equals 1/2 circle. or more specifically, 1/2 circular rotation. So 180 in the positive direction looks like this. 180 in the negative direction looks like this. So positive 180 and negative 180 put you in the same place. But we have 210 and negative 210. Since 210 is bigger than 180, so this 210 right here is going to take us a half circle and then a little bit more. So this green one is negative 210. Not a little bit more. What I mean by a little bit more is an extra 30 degrees. So 180 plus another 30 gives you 210. Puts you over here in quadrant 3. But negative 210 going in the negative direction. So half a circle is 180 plus a little bit more. Another 30 degrees. So this would be negative 210 degrees in green. And that puts you in quadrant 2. Quadrant 2. Sorry, my chair is squeaking. I don't know how long I've been doing that. I just realized it. Okay. So my next question is, what is the biggest possible angle? Well, you may say it's 360 degrees because that's a full circle. But that's not actually true. That's not actually true. Right? You could have an angle. So like, let's say initial side. And then the angle does this. Goes all the way around. Goes all the way around again. And it stops, I don't know, over here. Right, so 2 full circles plus a little bit more. So you could have an angle of 500, 1,000, 1,000,000 degrees, whatever. All right, angles can be any positive number, any negative number, also could be 0. So we have the potential for 2 different angles putting you in the same spot. Think about a clock, right? Let's say on a clock, right? This clock right now says 1 o'clock, right? That clock says 1. There's no AM or PM, it's just 1. In 4 hours, 4 hours after 1 o'clock, it is going to say 5 o'clock, right? That's 4 hours later. After 1, 4 hours go by, it's 5. Well, in 16 hours, it's also going to say 5 o'clock, right? The clock face is going to be the same because 16 hours, every 12, you're back to where you started. And then 4 more gives you 16. So 4 hours, 16 hours, same time on the face of the clock. So the same phenomenon is happening with angles. So the word we have for this is coterminal. Two angles are called coterminal. If they have the same terminal side. Same terminal side. So for example, think about 10 degrees and where that is on the circle. Well, it's a small angle, 10 degrees. So maybe about right there. $10. Okay, well now think about the angle, I don't know, 370 degrees. Well, 370 is equal to one full circle plus 10 degrees, right? One complete circular rotation takes you back to where you started. So 370 would go around the whole circle. That's 360 plus another, plus another 10. Put you in the same place, same terminal side, same location on the circle. So 10 degrees and 370 degrees are coterminal because they put you at the same location on the circle, same terminal side. So find a positive angle less than 360. So somewhere in the range 0 to 360. That is coterminal to 640. I got to erase what's on the screen, so I need some room. So what we can do here is take 640 degrees and subtract one full circle. That's going to put us in the same place. One full circle is 360 degrees. And 640 minus 360, I think that's about 280 degrees. Right, so these two are coterminal. If you rotate from the positive x-axis 280 degrees, and if you rotate 640 degrees, put you in the same place. Now you may have, like, if we start off with a larger number, like, I don't know, 1,580 degrees, you might have to subtract a circle and then another circle and then another circle until you get down below 360. In this case, it was just one circle, brought us below 360. Okay, anything we could do with degrees, we could do with radians. Find a positive angle less than 360 that is coterminal with 23 pi over 6 I shouldn't have said 360. I should have said less than 2 pi. That's my mistake. Find a positive angle less than 2 pi. So between 0 and 2 pi, that is coterminal to 23 pi over 6, right? That's bigger than 2 pi. That's bigger than 1 full circle. So we subtract 1 full circle. And 1 circle we know is 360 degrees, or 2 pi radians. Get used to radian measure, because we are going to be working with radian measure much more than degree measure. We're going to be working with radians a lot more than degrees. All right, so 23 pi over 6 minus 2 pi, what is that? I don't know. We need a common denominator. 23 pi over 6 minus, we need a over 6 here, so that's going to be 12 pi over 6. Get a common denominator. 23 minus 12 is 11. So we got 11 pi over 6. So this many radians and this many radians are coterminal. They put you at the same point, the same location on the circle. Okay, so that's more or less everything. On the next slide, which is just there for a little bit of convenience, a little bit of foreshadowing. There are going to be some angles that are more important than others. So I want you to think back. If you took geometry in high school, there were a couple of triangles in geometry. Couple of right triangles. There was the 30, 60, 90 right triangle, and there was the 45, 45, 90 right triangle. And these were pretty important in the context of geometry. And it turns out there will continue to be important. So all of these labeled angles on these two circles, it's the same circle. One is going in the positive direction, one is going in the negative direction. But all of these multiples of 30, 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and then 360, because 0 and 360 are coterminal, right? All of those multiples of 30, those are going to be significant later in our next couple of videos, our next few videos. Those are the angles we're going to be really focusing on. Multiples of 30. Also, are multiples of 45. 0, 45, 90, 135, 180, 225, 270, 315, 360. There's some overlap, right? Because there's some, 90 is a multiple of 30, but it's also a multiple of 45. So these values on here, right? Get used to them, get familiar with them. we're going to be coming back and using them over and over and over. Okay, the next thing to do from here is to start talking about functions. Not going to do that in this video. We are done. I've talked about angles and angle measure, degrees versus radians for a while now. I don't know, it's been an hour, hour and a half, however long it's been. I know if you've made it this long, it's been a while. In the next video, there's going to be a number of videos after this one. The next place to go from here, we've talked about angles. We've talked about angles. The next place to go from here is plugging angles into functions. Right, plugging angles into functions. So we have to define these new types of functions that work with angles. We're not talking about linear, quadratic, polynomial. We're not talking about rational or exponential or logarithmic. We're going to be talking about these new, we call them trigonometric functions. All right, that is it. That does it for this video. I hope this was helpful, and we'll pick it up in the next one.